Good morning, everyone. Thanks for joining me today at Happy Big Data Minds Europe. Today I will talk about how did we transform our traditional batch pipelines to real-time insights in 3 minutes in payment analytics, of course. I will be covering our current architecture challenges, what is our solution design, and long-term vision on top of this. I actually realized that I put too much animations. I will try to not talk about every item, so please, sorry about it. Let's talk about shortly who is Delivery Hero. So basically, Delivery Hero is founded in 2011, headquartered in Berlin, actually. We are global food delivery platform. We operate more than 50 countries and 4 continents, but not in Germany. Actually, we just sold the branch, I think 5 years ago. But the brands you may know, Foodpanda, Foodora, Pedidosia, Glovo, like this kind of brands all around the world. The company we process actually more than 1 billion orders annually. And since I work under fintech department, I can tell you that we have integration more than 100 payment service providers worldwide. And what is our challenge? This brings unique complexity. So only traditional batch pipelines wasn't enough for our insight and our business teams. That's why we had to transform to real time. So, what was our vision? Like I mentioned, we want to transform our payment analytics through real-time data processing to create real-time insights. We already had a challenge from the beginning. Our payment engine operates on AWS, but we have a data mesh structure on top of Google Cloud. That's why we had to build a pipeline between AWS to Google Cloud. And we had 7-week implementation plan. And we collaborated with payment engineering, data engineering, payment analytics, and business operation teams. Our key objectives: we want to reduce data latency from 24 hours, like event to insight, to 3 minutes. We want to enable real-time observability for data-driven decision-making and payment performance monitoring. And before this project, what was our critical pain points? Like I mentioned, event to insight, we need minimum 24 hours. And with this many orders, it brings like very big latency on decision-making and operational visibility. If I talk about operational challenges, it was really hard to detect issues in short time. It was only after 1 day. And when there is one payment service provider is down, we only understand it on next day, and we cannot solve we cannot give reactive solutions. We cannot solve the problems with proactively. We need to have only solutions in next day, actually. If I talk about business impacts, it will also affect their insights, and if they want to check payment acceptance rate, it will take 1 day actually to understand what is wrong. So, before our new solution, I want to talk about what do we have in existing structure. Like I said, we have a data mesh solution on top of Google Cloud, and we have traditional batch pipelines running on it. Our payment engine runs on AWS, PostgreSQL, which is our transactional database for our payment transactions. And we use Apache Airflow as an orchestration tool to daily fetch this data to our BigQuery, which is our data warehouse, distributed data warehouse provided by Google. Then we visualize this data by using Tableau, but it takes 24 hours from event to insight. which is not acceptable for payment success rate. With this new approach, our data source is not changed, still same, but we start to use Debusium. Debusium is think like a detective, which watch your database changes and report everything. Then we have pops up on top of it. Since we use Google Cloud already, we didn't want to go for some other solution, and it was also, since we have a small team, it's easy to use some managed service solution, such as pops up. On top of that, we have data flow. Again, this is serverless, so if your data load become very big, it doesn't matter, it auto-scale itself and solve data processing issue by themselves. Again, we continue to use our BigQuery and visualization with Tableau. So in the final architecture, we keep our batch pipeline. We implemented our real-time solution. We basically wanted to use Lambda architecture. So when we need to use real-time insights, business team can directly check our real-time data, but when they want to be sure that there is nothing missing, they can always use batch flow for backfill or historical analysis. So how did we choose these tools? Yeah, for Debusium, like I mentioned, our management team clearly mentioned that we shouldn't bring any load on production systems. And just by using Debusium, just checking log information, we did actually a very small amount of load. Then, we use Google Cloud Pops Up. This is a messaging queue service. We didn't use Kafka. It's actually the most popular one on this field. Main reason, we didn't need a transformation on millisecond level. Like second level transformation was enough already for us. And it's also easy to maintain. And when there is an issue, it's easy to solve. This is also a managed service. Data flow is managed service version of Apache Beam. Again, in this field, maybe we could have used Flink or Spark, but we choose data flow. Mainly, it's serverless and easy to use. And schema evaluation handling. So I believe data is alive, so it will change during the time. It will be failures. So we need to be careful about what do we implement. In our solution, when there is a new column or new table, we automatically handle this kind of changes. For data storage analytics, we continue to use our BigQuery for our raw and curated layers for our data marts. We use some materialized view for real-time data applications. And like I mentioned, we use Lambda data processing architecture mainly to be safe and fast. So for historical analysis, customer can use, business teams can use our batch data. For real-time decisions, they can go with real-time. Of course, we had to think about different perspectives, such as security. Since we are transferring data from different cloud platforms, from AWS to Google Cloud, we had to think about data encryption during transit and at rest. We used the security features provided by Google Cloud itself. And there is also a feature called workload identity federation. Basically, we choose which AWS account can access our Google Cloud. We only gave access to our own payment engineering AWS account ID, so no one else can push any data to our system. And of course, for GDPR reasons, we had to handle PII data from the beginning. So customer information already masked from payment transaction database to Google, our data warehouse. So we had no issue with GDPR. So like I mentioned, we are expecting to see failures. It's very common in data world. In every step, we set some auto-recovery mechanisms, error handling in each stage, like in data flow, in Debusium. And we have daily consistency checks with our real-time data and batch data if there is anything missing or inaccurate. And we set up some monitoring and alerting on top of it. So what we monitor actually? In Debezium, you need to check, do you send all events on time to data flow and pops up properly? In data flow, are we processing everything on time? We set monitoring on top of these tools, and we set alerts, such as if there is any lag more than 5 minutes, basically, in the data processing, we trigger an alert. Okay, please check messaging service. We are not able to acknowledge or process these messages more than 5 minutes. We had such alerts on top of it. And in case of any failures, we basically detect everything, and we have some guidelines how to work with them. So all the project took 7 weeks, like I said. We started with Europe region. Main reason, we wanted to make a POC, validate the architecture, and test the performance. After that, we deployed on US and APAC. Then all the regions were already deployed at the November 4th, 2024. So this is actually one of the important parts. Normally, real-time processing costs a lot. But with this solution, we only add annually to our bill $26,000. And I should mention that we process currently more than 80 million events daily. And this is our total cost, basically what it brings, just having all this real-time architecture. And in our success stories, so basically we enable our real-time analytics. Now we are able to detect issues immediately if there is any problem with payment service providers. That help us to enhance our operational efficiency and decision making. I mean, we had 2 dashboards on production database before, which is not properly implemented. And they were costing, just these 2 dashboards, costing $250,000 annually. We directly saved on them, but this is not our main saving. We also avoided potential Kafka cost. Key metrics we achieved. Now insights are available in less than 3 minutes. We have no any missing data. We process more than 80 million events per day. And we didn't impact production systems at all. And long-term vision. So it was extended data sources, first one. We actually already doing it. Since the project is very successful, now we are giving this service to our anti-fraud team. They are also using this service. We are working on machine learning capabilities, but the most important point is predictive capabilities. Since we work with 100 payment service providers around worldwide, they can be down time to time. So we have to be aware of it, and we need to do redirection between different payment service providers to make customer pay. Because if the payment fails, most of the time customers change their mind about giving order. So we lose order because of the payment. And with this feature, we can directly redirect customer to active payment service provider on that country. And if there are multiple available ones, we can use actually cheaper one and to increase GMV. Currently, actually, we also deployed this, but I couldn't measure it yet. But this is the main motivation to implement all this real-time analytics. So that's how we enabled our real-time insights. Thank you for listening.